Problem 5. My chloride anion is going from a -1 to a 0, and my manganese is going from a +4 to a +2. I know it's going to a +2 because I can recognize that sulfate anion, and that's a kind of a quick way to figure that out. So sulfate is -2, so I know the Mn has to be +2. All right, go ahead and pause and work out the half reactions and combine them into a redox reaction. And here's the complete combined redox net ionic equation. So now let's figure out how to put that back into that molecular form. Let's start with the 4 H pluses. So those would have come from the H2SO4. And because it's H2SO4, those 4 H pluses are going to come from 2 molecules of sulfuric acid, H2SO4. The Cl minuses are going to have come from 2 formula units of NaCl. So I know I'm going to have 2 sodium spectator ions also on the right-hand side that are going to combine with something. And in fact, those 2 NAs are going to end up on the product side as part of Na2SO4, because that's the only species that contains Na on the product side. So now watch this. I've accounted for the hydrogens on both sides, and I've accounted for the sodiums on both sides. We've accounted for the 2 Cl's on both sides because there are 2 Cl's on the product side in the form of Cl2. But now I have this issue with the sulfate. So on the reactant side, I have 2 sulfates, and I only have 1 sodium sulfate because of the 2 sodiums, and there's only 1 sulfate anion in that 1 formula unit of sodium sulfate. So where is that other sulfate going to end up? And if I look at the top equation, I see sulfate present also in the manganese sulfate. Aha! So the other sulfate is going to combine with that Mn+2. So that's going to take care of the other sulfate. Aha! So let's go ahead and rewrite our molecular equation. Fully balanced. So I have 2 sulfuric acid and 2 sodium chloride and MnO2. That's going to make Cl2 and manganese sulfate and water, 2 waters, and don't forget about that sodium sulfate on that product side. There's the final equation.